Hi students, this is Professor G. Ilangovan from NPR College of Engineering and Technology. You are watching the video series of CS 8351, Digital Principles and System Design. This is for Unit 1, Boolean Algebra and Logical Gates. And in this video, we are going to see about different binary codes involved. So basically, the binary codes can be classified in different methods. In that, we are going to see what is weighted codes, what are non-weighted codes, what are reflective codes, what are sequential codes, what are alphanumeric codes, and what are the error detecting and correcting codes. So in the binary numbers, we have this general classification of different kind of codes. So this can be shown in this diagram as shown in this. So if you are saying an weighted code, each bit position will have a fixed weightage. So that will be called as weighted codes. And non-weighted code is, it does not have the fixed positional values, will be called as non-weighted code. And the weighted code example is the conventional binary numbers and BCD codes. These are all weighted codes. And for non-weighted codes, XS3 code, gray code, these are all falls under that category. And reflective codes, a code will reflect you this, it's self-complementing. In other words, a code for 8 and its complement is going to be 1. So it's going to be self-reflects. And sequential codes, in sequential code, always the lower order number is lesser than the higher order value. So all the weighted codes falls under the sequential codes. And alphanumeric codes, apart from the numbers, we need to store characters and special symbols. So the special characters or symbols, these are the things to be stored. So its equivalent binary value will be assigned. So that will be called as alphanumeric code. And when transmitting from one place to another place, there is a possibilities of changing a bit or more than one bit. The bit value become 1 to 0 or 0 to 1. So this change of bit will be called as error occurred in the data while receiving. So this has to be detected and to be rectified. For that, error detection and correcting codes are available. And if you are coming to the weighted codes, there we are saying that BCD codes. The BCD codes are weighted codes since each bit position will have fixed positional values. And binary coded decimal or BCD is the conventional number 0 to 9 will be represented with its 4-bit binary equivalent from 0 to 9. So that has been shown in the table. Say if you wanted to write a number, say if you wanted to write 396. So 3 to be converted, its 4-bit equivalent 0011, and 9 to be converted, its 4-bit binary equivalent 1001, and 6 to be converted, its binary equivalent 0110. So such a way that we will be doing that. So when we are adding the two BCD numbers, it's going to be so conventional. And there the when we are adding two numbers, two BCD numbers, it may reaches to the invalid BCD combinations, because if you are having 4 bits to represent a number, there are 16 combinations. But in BCD, only 10 become a valid and remaining 6 become an invalid. So when you are adding two numbers, the result may be an invalid BCD. Whenever we are coming with the invalid BCD, it has to be overcome by adding 6 with that. That is called as the adjustment to the BCD. Or if there is a carry is generated, by the time also we are adding 6. to make the result as a valid BCD. The other form of binary codes are the well-known 8421 BC binary codes and 2421 codes. These are all the other decimal codes, and of course XS3 code and 84 minus 2 minus 1 codes. These are all the other binary codes available. And one more code, important code, is a gray code. It falls under the non-weighted codes because the gray code does not have any fixed positional weightage. So each binary position will not have the fixed values. So the gray code advantage is the successive values will differ by only 1 bit. So it requires less amount of current to change over the switches from one place to another place. So also it will be the gray code, sometimes referred as a unit distance code, because of its nature of only 1 bit position is changing in this successive value. So decimal value, its corresponding gray code value is shown in the table. And if you are looking any adjacent values in the it will be always, it differs by only 1. So it mainly used in the for the purpose of error detection and representing analog values, and its advantages low power design. And the other one is the alphanumeric code. So this is the famous one of the thing is ASCII code, American Standard Code for Information Interchange. So as I already mentioned, it is for the purpose of storing numbers, alphabets, and special characters. So it uses the 7-bit format, 3 bits to represent columns and 4 bits to represent rows. So in the tabular column, the each value is represented. For example, if you want to represent alphabets capital letter A, then its binary value is going to be 1000001, that is 41 in hexadecimal format. In similar fashion, if you want to represent in the lower case, that will be a 61. And if you want to represent a number 5, decimal number, its equivalent value is going to be 35. And special characters, the printable special characters and non-printable special characters, everything will have the ASCII values. It will be maximum useful when you are using the keyboard. When you are pressing a key, so it is going to generate an ASCII character. So the keyboard is arranged in the matrix format, so it resembles that matrix format. So what is the table you are seeing now? It is the similar format the keyboard has been arranged. And the next one is the error detecting code. When we are transmitting a data from one place to another place, there is a possibilities of changing a bit value, that is called as error. That error may occur due to the internal or external factors. So anyhow, in the data communication, when the data are transmitted from one place to another place, there is a possibilities of occurring the error. So that error to be detected and to be rectified. The first case is if a system is capable of detecting occurrence of error, will be called as error detecting code. For that purpose, we are using the parity bit. So the parity bit scheme is used to count the total number of ones occurred in the transmitting scheme. When you are going for a parity, there is two kind of parity schemes are used: odd parity scheme and even parity scheme. So if the data transmission system is using even parity, that means all the data transmitted from one place to another place must be always even number of ones. If it is an odd parity scheme, all the data transmitted over the channel in all the time should be the odd number of ones. So how to make it as an even number of ones or odd number of ones? For that purpose, Along with the data, one bit will be added, that will be called as an parity bit. So if the data or the message bit is counted, if the system is, you assume the system is an even system, so all the numbers in the message must be always even numbers. So if you are counting the total number of ones in the message, if it is already even number, the additional bit become a 0 and it will be transmitted. If you are counting the message bit, how many number of ones are there? If it is an odd number, then we will be making the parity bit as 1. So the total count become an even number. So such a way that we will be transmitting. So in this way, if we are transmitting the data always in even number of ones in each message, at the receiving side, before extracting the information, it will be counting the number of ones presented in the message, and if the total number of ones is even, it is assumed that there is error free. If there is odd number of ones is available, then it indicates that the error was occurred. Similarly, if the system is an odd parity scheme or odd parity system, the total number of ones presented must be odd number of ones, such a way that we can detect the occurrence of error. But by using the parity scheme or parity bit, we are able to only detect. We are unable to locate in which place the error was occurred. For that, we are going for the Hamming code. So it was developed by Hamming. So with the help of Hamming code, we are able to locate in which place the error was occurred. So that also can be rectified. About this Hamming code, in another video, it has been clearly given. You can refer in the uh, fourth unit. So there, error detection and correction code, there is a separate video. The students can see that video to get into more information about the Hamming code, error detection and correction. And students, in this video, we got introduced about the different binary codes: weighted code, non-weighted code, reflective codes, sequential codes, alphanumeric codes, and error detection and correcting codes. Thanks for watching, students. Thank you.